In this class, we are going to look about building materials. First, among the building materials, it's concrete. Concrete is usually defined as a mixture of cement, sand, coarse aggregate, which is gravel, and water in the correct proportions and thoroughly mix it. So upon setting, it forms a rock-like mass. It is particularly suitable for foundations, pillars, walls, floors, and for constructing water tanks. It is comparatively stronger and more durable than brick masonry and especially adaptable to watertight constructions. But the cost of construction is comparatively higher. For best results in concrete work, the following procedures should be observed, which are: the first is all the aggregates are in the proper proportion. That means we need to make sure that all the aggregates that we are going to use are in an equal proportion of size. And second is the coarse aggregate is properly washed and sand is sieved. And the third is thorough mixing of the ingredients is done. And the fourth is careful pouring and thorough tamping is done. And the final one is after the concrete is laid, the proper curing should be done for a period of about a week or 10 days. Strength and economy are the two important factors that determine the mixing proportions in concrete. Generally, the quantity of water added to the mix should be such that an easily workable mixture is made. It should be neither too wet nor too dry. It should be a plastic semi-fluid mass which, when flattened with a steel towel, should produce a smooth surface showing free water particles on the top and should form a cone-shaped pile when heaped at a place. Concrete has attained the status of major building material because of the following reasons, which is the first one is it can be readily molded into durable structural items, and the second is it can be formed to a desirable size shape with a low labor expenditure, and the third one is proportions can be varied with the change of ingredients and by employing special processing techniques, and the fourth is it possesses adequate plasticity for mechanical working. The fifth one is the ingredients are easily available, and the sixth is the maintenance cost is negligible, and the seventh will be the concrete of the compressive strength ranging between 300 and 700 kg per centimeter square, which is 30 Newton meter per meter square and 70 Newton per meter square, can be easily prepared and are used in construction of different structures. The properties of concrete. The cement concrete possesses the following properties, such as it has a high compressive strength, free from corrosion at atmospheric weather, strength improves with age, hard surface is resistant to abrasion, prone to shrinkage due to evaporation of water and developing hardness. Concrete is designed in 7 grades, namely M10, M15, M20, M25, M30 and M35 and M40, depending upon the specified compressive strength of the mix attained at 28 days. For lean concrete bases and simple masonry walls, M5 and M7.5 grade concrete may be used. Grades of concrete lower than M15 are not suitable for RCC work. M5 and M25 grade concrete attain the strength at 28 days as 6 Newton meter per meter square and 25 Newton meter per meter square using 1:1:5:10 and 1:1:2 composition of mix respectively. For testing the concrete mixture, we have there is a test known as slump test, which is it is performed to measure the plasticity of the concrete. A slump cone made up of steel metal is used for test. This is 30 cm high, having diameters of 20 cm at the base and 10 cm at the top. The cone is placed on a level surface and filled with concrete, settle about 2.5 cm below the 30 cm height. It can be used for plain or reinforced concrete work. If it slumps more than 12.5 cm, it should be rejected. It is generally believed that the strongest concrete is one in which the pore space between the coarse aggregate is just filled with the fine aggregates, and the pore space between the fine aggregate is just filled with the cementing material. And for particular condition, the formula developed by Fuller is used for estimating the quantities of aggregate required for a mixture of 0.76 cubic meter The fuller formula is given by C is equal to 42 by small c sum of small c s and r, where capital C is the quantity of cement in uh, cubic feet, where and small c s and r are the proportion of cement, sand and gravel respectively. The relation of water to cement is also an important factor which determines the strength of concrete. Water cement ratio by the volume for hydration hardening of cement theoretically works out to be 0.08, but a ratio of 0.66 to 1 is generally found to be suitable from a practical point of view. Before pouring the concrete on the job, it is thoroughly mixed either by shovel or by means of mechanically operated concrete mixtures. Having poured the concrete, it is vigorously tampered and rammed by the means of mechanical pneumatic vibrators or by shovels. Mixing helps in strengthening the concrete by forcing the smaller and larger aggregate close together, thus making the mass more compact. Placing and compacting the concrete. The concrete should be deposited on clean surfaces which are well watered. For vertical lying, stiff mix should be poured, whereas the horizontal layers of not more than 15 centimeter thickness be laid to avoid water appearing on the surface, which is the upper layer. And during placing, it should be seen that all the edges and corners of concrete surface remain unbroken, sharp and straight in line. Compacting of concrete is done to achieve maximum density by removing air voids from the concrete. The strength of concrete reduces considerably by the presence of even 5% voids due to poor compaction. Also, care has to be taken to avoid voids at the joints where hardened and fresh concrete are laid in layers, where the vibrators are not used. The compacting by shovel or steel rod with flattened end is essential. Thus, manual compacting is done by rodding, tamping or ramming. These methods of compacting are preferred for vertical sections, slabs and heavily reinforced concrete section respectively. Ramming is stopped when water appears on the upper surface of the concrete. Curing. Now, curing of concrete is the process of strengthening it through hydration. Moisture is necessary for good curing. Generally, the concrete surface is flooded with 2 cm of water or covered with moist gunny bags or moist sand for a period of about 7 days. The international standard number 456 in 1978 stipulates a minimum of 7-day moist curing, while the other regulation states that it should be done for a minimum of 10 days under hot weather condition. And these both methods give the same strength after 28 days of curing of high water cement ratio. At lower ratio, the ponded curing gives higher strength. By this time, the concrete gains about 90% of strength. The rate of increase in strength is rapid at beginning, but the strength continues to improve for many months. However, curing is discontinued after about a week or two. Finishing. Except for a few cases, concrete floors and surfaces are given a surface finish by means of a wooden float, followed by a steel trowel just after concrete is poured. In order to obtain a very smooth and polished surface, finishing is followed by polishing with some hard grinding stone. Generally, this is avoided as polished surfaces tend to be slippery. Reinforced concrete. Concrete is low in tensile strength, but it can withstand high compressive strength. Steel can withstand both tensile and compressive strength. Steel reinforcement is provided in concrete to withstand tensile loads. Reinforced concrete has steel bars placed in it to take the tensile stress and some of the compressive strengths also. For example, the reinforced concrete fencing post, the reinforced concrete beams, where we can see that the rods are being placed inside of a post, and thus the reinforcement is achieved. And these are example for these are examples available of used items in farm structures and for farm fencing jobs. Concrete beams which supports the load from top tend to bend, developing tensile strengths at the bottom. To overcome these strengths, steel bars are placed at the bottom end of the beam as reinforcement. Similarly, the posts after being placed on the farm boundary with strengthened barbed wire are subjected to tensile strength on being pushed by the stray animals. To overcome that, four-cornered steel bars placed in the post resist the tensile force. Steel being equally strong in compression and tension but having bulking tendency is ideally suited for reinforcing work. A combination of two, which is concrete and steel, make them best suited because two materials are employed to resist the stresses they are most suited. The combination of concrete and steel is in construction is known as reinforced concrete. The concrete develops very good bond with the surface of steel bar. Hence, the concrete transmits the excessive strength which it cannot resist itself to the steel reinforcement. As the coefficient of linear expansion of the concrete and are nearly the same, internal stresses do not develop in reinforced concrete due to temperature variation. Reinforced brickwork. In a reinforced brickwork, whole bricks are laid regularly with reinforced between bricks. The total reinforcement is preferably divided into smaller cross-section bars so as to get better bondage between them. Cement. The term cement is usually applied to the product known as Portland cement, which is defined as the product obtained by finely pulverizing clinker produced by calcinizing to incipient fusion and intimate and properly proportioned mixture of aggregaceous and calcareous materials with no addition subsequent to calcination excepting water and calcinite or uncalcinite gypsum. The calcareous materials, which constitutes 75% of the total weight of cement, may be limestone, chalk, shell, or a combination of these. The argillaceous material, the remaining 25%, consists of clay, shale, or blast furnace slag, or a combination of these. These ingredients are mixed in a very exact proportion. The mixture is thoroughly ground and heated to the beginning of fusion about 1550 degrees Celsius in a large cleanse and then allowed to cool. Finally, about 2 to 3% of gypsum is added and then the mixture is ground to a very fine powder, after which it is packed in a synthetic jute bags to be dispatched for use. Each bag full of cement weighs about 50 kg and is 0.35 cubic meter in volume. Depending upon the specific use, the cement is, can be classified as regular type cement, white cement, quick hardening cement, and where the regular type cement sets within 10 hours and develop its full strength in 28 days if properly cured. The white cement is identical to the regular cement and it is in its characteristics, but it is whitish in color. It is generally used for ornamental work. The quick hardening cement develops its full strength within 3 days after setting. After 1 day, it should develop strength not less than 20 kg per centimeter square and 30 kg per centimeter square after 3 days. It may be used for sealing the passages of water oozing out of soil pores and for similar other jobs. Composition of Portland cement. As we discussed earlier, the ordinary cement consists of 3 ingredients such as siliceous and calcareous. Clay, silica, and calcium carbonate, respectively, predominant in argillaceous, silicous, and calcareous material. The raw material used for making Portland cements are limestone, silica, alumina, iron oxide, magnesium, sulfur, calcium sulfate, and alkalis. We can see that in a table, which is these are the these are the ingredients, and the percentage of each ingredient is given here, and also their nature of work in binding in the RCC is also been explained, which is a lime in the percentage of 60 to 75, and excess is undesirable, deficiency improves setting. Silica, which is used in 20 to 25%, it imparts strength, but excess quantity prolongs setting. Alumina in 4 to 8%, it imparts quick setting, and excess quantity weakens the cement. And iron oxide in 2 to 4%, it imparts hardness and color and strength. Magnesia in percent of 1 to 3%, it imparts hardness, color and strength, and however but still the higher quantity is not acceptable here. Sulfur we used in 0.5 to 1%, and calcium sulfate of 0.5 to 1%. Its presence makes the cement a sound product, and calcium sulfate it is in the form of gypsum. It is to increase the initial setting time, and its presence avoids the immediate setting after water is added. And alkalis are used in trace amounts. And ordinary Portland current, it is also called normal setting, since its setting is normal when mixed with water. It is suitable for use in general concrete construction work, which requires no special consideration. It should satisfy all the requirements as per the standards, and for good cement the strength should not be less than 20 kg per centimeter square, and for 3 days, and 26 kg per centimeter square after 7 days. Rapid hardening cement, it is a different chemical composition and greater fineness as compared to ordinary Portland cement. It needs more water for same workability. The high strength at early stage is achieved due to increased lime content, burning at higher temperature, and finer grinding. Quick hardening cement, it is used only under special circumstances, and should be avoided in general use. Due to slow pace of work in mixing, pouring, and placing on the jobs, the cement sets initially in 5 minutes and finally in less than 30 minutes. Packaging and storage of cement. Packaging of a cement in India is done in synthetic woven bags, which contain 50 kg material. Use of gunny or jute bags is presently not being done due to high cost and restriction imposed on them by the government agencies. And cement bags are usually handled 4 to 5 times in normal transportation, and handling systems being practiced in India. Cement retains its good quality almost indefinitely if the moisture is kept away from it. The cement exposed to air absorbs moisture slowly, and this causes its deterioration. An absorption of 1 to 2% of water has no appreciable effect, but higher amount retards the hardening of cement. Cement in bulk can be stored in bins of 2-meter depth. Bagged cement can be stored for many months in waterproof shed. Lime. Lime refers to the type of material used in building construction, composed of calcium carbonate. Pure lime is prepared by calcining, which is heating to red hot limestone, the limestone or shells of sea animals over a given burning period, with the result that the original elements is split up into calcium oxide and calcium dioxide, which escapes into the atmosphere. Calcium oxide is a friable material known as lime or quick lime. In order to make use of lime, thus prepared for building construction, water is added to it. The material undergoes a change accompanied by the heat and effectiveness, air bubbles, and steam being discharged. The combined state thus obtained is called as slacked lime or hydrate of lime. The process is called slacking. The slacked lime that is available in the market acquires the power of absorbing carbonic acid from air in the presence of moisture. so it should be stored in a dry place. To be used as mortar, lime is used with fine aggregate, which is sand and water, and the setting and hardening of a hydrated lime takes place by the gradual and lengthy process of absorbing carbon dioxide from the air and the evaporation of excess water, leaving solidified crystals of calcium carbonate. The strength of lime mortar increases with an increase in the fineness of the sand particles. Limes are classified into several groups on the basis of the proportion of calcium and magnesium contained in them, such as fat of pure lime containing 95% of or more calcium oxide, poor or lean lime containing less than 95% of calcium oxide, hydraulic lime containing 15 to 30% clay in it, magnesium lime containing 10 to 25% magnesium oxide, dolomite lime containing over 25% of magnesium oxide. Sand is generally known as fine aggregate. It is always smaller than 2 mm in size. The two classes of sand which are commonly used as building material are coarse sand, which is 1.5 mm, and fine sand, which is 0.2 mm. According to MIT, the sands can be classified as fine sand, where the size of the aggregate varies from 0.06 to 0.2 mm, and medium sand, where the size varies from 0.2 to 0.6 mm, and the coarse sand, where the size varies from 0.6 to 2 mm. The fine aggregates may be natural sand, crushed stone sand, or crushed gravel sand. Sand used in India is generally collected from the riverbeds. It should be free from organic matter and clay. The sand with an excess of silt and clay is unsuitable, as an aggregate becomes clay, interferes with the proper hardening of cement, and thus reduces the strength of concrete or mortar. And there are several tests performed to test the suitability of sand as a fine aggregate, and which are first is take a sample of sand to be tested in a glass jar or bottled upon a depth of 5 cm, and then fill half to 3/4 volume of the jar with clean water. Shake the jar for about 2 minutes and then let the mixture settle down for about an hour. Measure the depth of the silt on the top of the sand in the jar. If the depth of the silt is greater than 3 mm, it is not suitable to be used for concrete. Before using the sand to make concrete, it should be sieved so that organic matter and gravels are removed. Sieving is generally done by pouring the sand over an inclined sieve so that the foreign matter is separated, leaving the pure sand behind in a heap. Another defect which may be found in sand is the presence of soluble organic matter. If it is in excess, it prevents proper setting and the hardening of the concrete. For this, we can make sure performing a test where about 2 teaspoonful of NaOH is dissolved in 100 cubic meter of clean water in a jar. 100 gram of sand is added to a solution, and the mixture is thoroughly stirred for 2 minutes, and then it is allowed to settle undisturbed. If after a day the color of the solution in jar remains unchanged, then the sand is free of organic matter. If the color is dark, it should be not used for making concrete or cement mortar. Sand has a characteristics of increasing in volume due to addition of small amount, which is up to 5% moisture in it, but at higher moisture content of 15% or above, as well as under dry condition, it occupies the least volume. It is therefore necessary that while measuring the volume of the sand to be added in the mix, due to consideration is given to its increased volume, called bulking. It is important to note that the very fine sand expands most and a very coarse sand at the least. Surki is a ground break dust or a pulverized burnt clay, which is sometimes used as a substitute for sand in place where sand is scarce or otherwise uneconomical and unsuitable for the use of building material. Surki can be best made of brick, which is not useful otherwise as a building material. Generally, surki is not mixed with cement. It gives very good results with limestone. Gravel or coarse aggregate. Gravel and natural sands are by far the most common and are used whenever they are of satisfactory quality and can be obtained economically in sufficient quantity. Aggregate, which is a natural sand and gravel, are generally cheaper than cement and impart volume, stability and durability to concrete. It is used primarily to provide bulk to the concrete. It increases the density of the resulting mix. The aggregate is frequently used in two or more sizes. The most important of fine aggregate is to assist in producing workability and uniformity in the mixture. The aggregate provides about 75% of body of the concrete. The aggregate must be proper shape, either round or else approximately cubical, clean, hard, strong, and well graded. The aggregates, most of which are retained on the 4.75 mm IS sieve and contain only so much of fine material as it is permitted by the specification, are termed as coarse aggregates. According to source, coarse aggregates may be described as crushed gravel or stone, or uncrushed gravel or stone, and partially crushed gravel or stone, which is product of blending of the other two aggregates. The graded coarse aggregate is described by its nominal size, that is 40 mm, 20 mm, 16 mm, 12.5 mm, etc. The graded aggregate, most of which passes to 12.5 mm sieve. The size of a coarse aggregate used in making concrete ranges between 6 and 75 mm, which is 1 by 4th and 3 inch. It can be either broken rocks, brick ballast, water-worn pebbles, stone, coal, clinders, or slag from the blast furnace. The aggregate size about 7.5 centimeter and up to 22.5 centimeter are known as coarse aggregate, but they are generally not used in making concrete used on farms. The size of coarse aggregate to be used in is limited by the thickness of the job it is to be used for. For floors on foundation, the size preferred is 4 cm. Sometimes the gravel is dug out from the quarries. It contains a large percent of soil in it. It should be sieved and thoroughly washed in water before making the concrete mix. Some of the important natural soil formations used as gravel in their natural form are Kankar and Moram. Where Kankar is a variety of limestone containing about 15 to 30% of clay and sand in it. It is grey in color. The hard variety is used for making light traffic roads and also for building purposes. Moram is decomposed laterite, generally found close to laterite quarries. This is red in color and used for metalled roads. And singles are large water-worn pebbles found in riverbeds. They are used as a road metal or in concrete where better stones are not available. The material whose presence may be adversely affect strength, workability, and long-term performance of a concrete are termed as deleterious materials. These are considered undesirable because of their harmful characters to the concrete qualities. Any material used in the concrete should not affect the process of hydration of cement, the process of developing good bond between mortar and aggregate, and developing weak bond due to chemical reaction between the aggregate and the cement paste. The humus or organic substance present in the sand need to be washed to prevent happening of some or all the above undesirable action in the concrete. Some of the factors which are not much cared for but which affects the strength of the concrete are delay in placing of concrete, increase in the aggregate content, aggregate moisture content, temperature of curing and maturity of concrete, and loading rate. Mortar for a building construction usually consists of a mixture of cement, sand and water, or lime. Sand and water. The cement or lime provides the strength and durability, and the sand makes the mortar easier to handle and improves adherence to the bricks. Only clean and well graded sand should be used for making mortar. For most masonry joints, 3 mm diameter sand is preferable. A common ratio of cement to sand in mortar is 1:3, while for lime and sand, a good mix is considered to have the ratio of 1:2. Sometimes cement, lime, and sand are mixed in a proportion of 1:1:6 to be used as mortar on interior walls. The mortar used for masonry construction serves as the purpose of it binds the several units into one stable unit, and it fills the space between stones or bricks, thereby making the construction wind and waterproof, and it distributes the vertical load of masonry evenly throughout the mass. And finally, it also used as a plaster on walls and ceiling to give a pleasing appearance as well as to protect it from rain. Bricks are made from a clay which, when moistened, becomes plastic so that it can be easily molded into desirable shape and size. After being dried in the sun, bricks are baked in a kiln or for a long time. Brick earth. The average composition of a brick earth is 69% silica, 29% of iron, and 1 to 2% of lime and other materials. The clay for ordinary bricks used for building purposes should have a fairly low fusibility and low shrinkage. It should be free from pebble and alkaline and saline soils. Generally, the brick manufacturing work continues all the year around, except for the about 3 months during the rainy seasons. Brick earth is well prepared in presence of water by cleansing the clay under the feet until it becomes a soft mass. Sometimes earth is prepared by a mechanical device called pug mill. In India, brick molding is done usually by hand. When bricks are made on the ground, a large area is prepared by leveling and sprinkling fine sand. After molding, bricks are left on the ground to dry till they are hard enough to be handled. Later on, bricks are stacked in a form of perforated walls for further drying. The common size of bricks made in India are 20 into 20 into 10 centimeter. The length of mold is kept slightly larger than the finished side of the brick, so that the length of each brick just exceeds twice its breadth by the thickness of a mortar joint. The weight of a brick is about 4 kg. The tensile strength varies between 19.7 to 21 kg per square centimeter, whereas the crushing strength ranges between 56.2 to 70.3 kg per square centimeter. Burning of bricks that are prepared on small scale are burnt in a clamp or clamp in which the bricks and the fuel are placed in alternate layers about the ground level. These bricks are usually underburnt, which lowers the crushing strength of the brick. But for commercial use, bricks are usually burnt in kilns. The most popular type of kiln is a bull trench kiln. It consists of a circular or elliptical trench with semicircular ends excavated in the ground and lined in a masonry wall. There are openings in the walls of carrying off the smoke and draw air for keeping up combustion. And classification of bricks in India are classified as first class, second class and third class bricks. But first class bricks which are sound hard and well burnt and have retained the proper shape and size after burning. They have a deep red color and emit sharp ringing sound when struck with a hard material. Second class bricks are hard and well burnt bricks which are slightly disordered or with scratched on the surface. They cannot withstand continued exposure to the action of water. Third class bricks are bricks which are comparatively less hard and are not fully burnt. They should be used on walls exposed to rains. And the other types of bricks are overburnt bricks and sun-dried bricks and laterite lime bricks and building stones and waterproofing of mud walls. And overburnt bricks are those bricks which have been overburnt or called overburnt bricks. They are irregular in shape and size, dark blue colored, hard and brittle. They are preferred for building foundation, concrete making and road metalling. Sun-dried bricks, these bricks are not burned but only sun-dried. They are used in wall construction which is one way superior to mud wall in strength. However, it gives much better appearance from outside. Walls made of sun-dried bricks can be perfectly vertical. Laterite lime bricks. Laterite is in abundance in eastern India and many other parts of the world. Laterite bricks are sun-dried and abundantly used for making walls of all types and thickness. Lime fly ash soil stabilized bricks can also be manufactured from thermal station fly ash. A normal size block of 15 to 20 into 20 centimeter moist cured for 28 days gives a compressive strength of 20 to 25 kg per centimeter square. Building stone blocks of regular or irregular sizes locally known as alanga are best suited for placing them in foundation and also for constructing boundary walls. However, the superior quality stones such as sandstone, ballast, marbles, kota, glazed stones are excellent flooring and wall making materials. These being expensive are generally used as fancy materials for expensive houses. Waterproofing and mud walls. Mud are most commonly used material for making traditional low-cost houses. A mud wall erodes due to impact of rainwater and it protects with cheap and efficient waterproofing material has attracted the attention of researchers and civil engineers. Waterproofing is done with a liquid prepared from a mixture of kerosene oil and molten bitumen. The mixture of about two materials is either sprayed or painted on the mud wall to protect the wall from erosion for 3 to 4 years. Timber and plastics. The wood used as components of engineering works like beams, pillars, rafters, purlins, door frames, doors, etc. is termed timber. The best quality timber is obtained from a trunk of a tree which has attained its maturity. Hence, it is important to fell trees for timber at a proper age. It is advantageous to carry out felling of trees during winter season. It is in most developed countries, timber is costly, and first class timber is mostly used for luxury houses or quality furniture. It would be wiser to use as many secondary species as possible to avoid such wasteful and discriminate use of first class timber. About 40% in weight of timber is wasted in cutting and sawing. There is a scope for collection and utilization of timber waste. Seasoning of wood is primarily done to get rid of all the surplus sap and the moisture so that the wood will not decay or to be affected by fungus. Seasoning also prevents the wood from wrapping due to uneven expansion or contraction of moist wood with a change in temperature. Generally, logs cut from trees are stored in ponds underwater. This process prevents the log from being attacked by wood borer as well as from cracking. The sap is diluted and thus washed out before the logs are removed. The wet log should be thoroughly dried before use. Water seasoned timber is less likely to wrap and crack. The other economical method of seasoning timber is to let it dry in open air under shade. This is called A-seasoning. The timber should be properly sagged and protected from direct sun, rain and wind. The method is best suited for seasoning sliced planks and timber rather than big logs. The third method of seasoning is known as kiln seasoning. Sliced timber in the form of planks stacked on beams is placed in a masonry chamber which is heated by means of steam or hot gas. The seasoning is over within a fortnight, which is about 1/6 to 1/8 of the time taken in the air seasoning. Besides seasoning, timber should be protected from decay due to fungi during use. As far as possible, timber should not be allowed to come in contact with damp earth. Timber should be painted as paint gives a protective coating. For outdoor work, application of a solution of copper sulfate containing 100 grams of salt to 4 liters of water helps to preserve timber. A thin layer of coal tar applied on the surface of timber is another effective preservative. Defects in timber. Defects in timber may be caused either by improper seasoning or by damage during felling or changes in nature while growing, or a combination of all these factors. Sometimes the fibers of the timber are injured by crushing. Occasionally splits are formed in the timber, either radiating from center towards the bark or curved splits. Sometimes ringales or ringles are formed, which is peculiar curved swellings. They are caused generally by the growth over the wound remaining after a branch has been damaged. The three kinds of timber commonly used in India for the superstructure of permanent buildings are teak, sal, and deodar. All of them are strong and durable timber for all conditions. If properly seasoned, the timber does not wrap and shrink. In addition to the above, the following the secondary species of timber which are used are babul, jamun, siso, sirsi, neem, mahu, tamarind, and mango. Bamboo, which grows abundantly in hot, humid tropics, is an excellent binding material. It is used for making walls, roofs, and supports while constructing variety of structures in India. Bamboo as reinforced in cement concrete has been tried successfully. The pre-treatment of bamboo against moisture swells, decay, and termite attack has also been tried with encouraging results. Bamboo mats with a well laid out cement mortar layer provides a good roofing material for humid regions. Some of newer development in building materials technologies are like wood cement products, coir fiber reinforced cement board sheets, corrugated asphaltite roofing sheets, magnesium oxychloride sawdust door frames, rice husk boards, wood chips boards, plywood boards, and synthetic waterproof sheets, plastic sheets, and pipes. Thank you.